Hello, fabricators. Welcome to another Fabric Coffee session at Microsoft Fabric Cafe. My name is Mehrdad Abdullahi, the community lead and Microsoft Learn expert at this amazing community, the Microsoft Learn community. So I'm super excited to start today's session, another Saturday at this here, 8 a.m. So let me see. We've got some. Yeah, greetings. Martin, hi all from Denmark. Yeah, welcome. And Deborah from Canada. Hey, from Canada. I'm also from Canada, from Vancouver. Which side of Canada you are? Cool. So let me start my slides today, November 16. The 15th session of Fabric Coffee at Microsoft Fabric Cafe. I'm super excited to have great speakers in our sessions, and so at Microsoft Learn community, we have a rich place actually to learn about Microsoft and Azure. Technologies, whatever that you want about them is there in the Microsoft Learn, and there are also the learning rooms in different expertise in with different learn experts. So if you join those learning rooms, you can just get support from your learn experts and also share and again gain experience from your peers. So you have a closer actually relationship with others in those learning rooms. And if you would like to join those learning rooms, you can just use this link, aka.ms/learning rooms, and then you can just choose your favorite learning room or learning rooms, especially Microsoft Fabric Cafe, which is concentrating on Microsoft Fabric. And we are here to provide and support the Fabric users in all levels. Actually provide learning contents and with live sessions, and in future hopefully we can go for the workshops and some educational contents related to Fabric. So it is a forum for everyone to learn, share, and grow skills together. Just feel free here, grab your coffee, and enjoy the Fabric. And in the bottom, we've got our social medias and YouTube channel. Feel free to subscribe on that. Then you're gonna be notified for any upcoming session or any content that is going to be shared soon. So in LinkedIn page, the QR code just will land you in the LinkedIn page. And there we just announce any updates regarding our sessions, or even the updates from Fabric Office, and also the link, the direct link for Microsoft Fabric Cafe learning room. Join Fabric Cafe in tiny URL. So there's a code of conduct for our community. I do appreciate it that you are always adhering to this. Actually, our code of conduct. Be positive. Use responsibly, and report any issue if there is any, and embrace diversity. And Microsoft Learn Challenge. As always, Microsoft Learn is with us in the any event that is happening around the world. And now we've got Microsoft Ignite in Chicago, which is going to be started in November 19th. For those who are going to just attend in person, good for them. For others who cannot, you can just register online and just choose your favorite sessions with great speakers again there, and just make your learning days. And with Microsoft Learn Challenge, which is going to be started at November 19, and the pre-registration is ready. You can use this URL to there, but the This challenge is going to a good opportunity to learn more and during the year end holidays. So let us know if you have any question with that regard. And for Fabric Coffee sessions in November, in the past 2 weeks, we had amazing sessions with the other speakers, and we have still 3 sessions in November. And today we've got Rui from Portugal. And so let me just invite him to the stage. Hey, Rui.
Hi, hello. How are you? Thanks a lot for having me.
It's our pleasure. It's our pleasure. Thank you for joining us and for your presentation in advance at Microsoft Fabric Cafe. There are some comments in the chat. Levent from Turkey. Good evening. Shami Munshi from UK. Awesome. We have Adil from Emirate. Nice. And Martin says, what is the primary goal of semantic link?
We are going to see that.
Yeah. Don't go ahead. Martin. No, cool. Awesome. And Martin from Denmark. So we have, yeah. Cool. Cool. Rui, I will hand it over to you. But before that, guys, please feel free to ask your questions in the comments. And if there's any, I will be at the stage for any upcoming question. But Rui will have 2-3 pauses during his presentation, and then we can just ask the questions from him. However, at the end of the session, like always, we have riddles and prizes. Just stay tuned. Listen carefully to what is presenting, and maybe the questions are coming from those information that is coming out actually from there. So Rui, your screen is shared, and yeah, stage is yours. Guys, grab your coffee. I'm not sure if you have grabbed it yet or not. I've got it, and I'm just enjoying this session.
Thanks a lot. I'm not grabbing my coffee because it's 4 p.m. here, so I can't drink no more coffee for today for me. But thanks a lot for having me in Fabric Cafe. So before I present myself, just a brief introduction to this session. So Power BI, as you know, has always been the final layer of data in our ecosystem. So we create data flows, data pipelines. We gather and transform our data and make that data available as the most refined and worked layer for final users. That is the semantic model or data sets, as before we called it. And this flow usually would stop there, and we would rarely that data from these models will be used for other purposes besides visualization and dashboarding. So today I want to talk to you about semantic link. That is a feature that is available, is GA in Fabric right now, and this feature will add a new layer of analysis and things that we can do to our Power BI models or semantic links via notebooks. So to introduce myself, my name is Rui Carvalho. I'm from Portugal, and I've been working with data for around 7 years, mainly with Microsoft technologies. And currently, I'm a data and analytics engineer. I work for a company also in Portugal, in Porto. It's called Bevscope. We do consultancy projects with data projects for companies around the world, mainly focus on Microsoft technologies, Databricks, and the majority is that. So one thing that I also love and like is to share knowledge, and that was one of the things that I started probably close to 2 years now. I started to writing some weekly blog posts on Medium about data topics, about day-to-day challenges that that I was having, not only technical but also on a professional level, and that kind of thing, that kind of share. Make me able to know a lot of good people, a lot of really interesting people that I still learn from them today. And I've also, in the meantime, I've also been started to participate in some events as a speaker for a year and a half now, and it was being a pleasure to be in events around the world and in this kind of in also in remote models like these kind of events, which is great. So thanks for having me. The agenda for today, of course, we are trying to cover as much as we can on semantic link. So let's see what this is, what this feature is, how can we use it in our day-to-day projects. Let's understand the data structure. So why is this different? What specifications semantic link will bring us to help us? Let's see some use cases. I will try to give you as much functionalities of semantic link as I can, but as this is basically a Python library, there's a lot of functionalities that I will not be able to cover in 1 hour, but I will give you the basics and some interesting things that you can do with semantic link, and probably you will pick that and you will start using on your own and start investigating and know a lot more so on what you can do. I will do Q&A in the end, but also I will have 2 points in the middle of the presentation for you to ask something if you want, and in the end, of course, we'll have the riddles. So pay attention. The answers are in the presentation. So let's start with what is the semantic link, in fact. So basically, the simple terms, semantic link is a feature that will allow us to query semantic models through the data science model in Fabric. Through the data science model using the notebook level with Python functions, basically. So the main goal here is to use the gold layer, so that which is the most refined layer of a data architecture, which in some scenarios are the semantic models. That's where all the data, all the specifications of a business are applied. So all that data was being transformed and worked with some rules, and it's pure validated, and usually that data is the source of truth for many for many in many scenarios. So the goal is to use that data and avoid redundant work between multiple areas and multiple teams. So the goal is to build this gold layer one single time through the semantic models that already exist in many organizations, and start using that data for something else than just reporting. Okay, so and in this way, we can use the semantic models not only for reporting, but also to apply some analysis, machine learning models, some validations that we may want to do, apply some automations on them. We will see that. And basically, in this way, we manage to create a complete data cycle. Like I really like this image that represents that well. So because we start gathering the data, we start storing it, we apply the transformations, and usually the cycle would stop there on the Power BI. And then we can make the full cycle because we are going to use that data again to basically to create a new cycle of that specific data. So giving life to that semantic model other than just reporting. One thing that is important here is the semantic link is based on a data structure, and for the ones that are already comfortable in working with PySpark notebooks, are probably used to these kind of data structures in Python. For example, Pandas data frames, Spark data frames. There's a lot of data structures, and there's still new data structures coming up. But basically, the semantic link is using one specific data structure that is called fabric data frame, which basically is a subclass of the pandas data frame that is one of the most used data frames when working with Spark. So basically, it is all the features available in pandas, as well as the semantic information and lineage of the structures it stores. So basically, we use these data structures to store information from our semantic models, and not only these will struct, for example, a table schema, but also this structure will be able to get things as measures, tables, relationships, dependencies, which basically can be used in all kinds of monitoring and validation after. So basically, Semantic Link has a large library of functions, like I've said, and methods that you can use on your data sets. So you can do simple things from listing tables and measures from your data set, read relationships and dependencies from your data, read table data into data frames and use that data for another purposes, run measures from your model, or you can execute DAX directly from your model in your Spark engine through a notebook. And one important thing is use that data to gather value from that. So, for example, you can use semantic link to find the data violations on relationships and on dependencies errors. And these are things like, for example, a relationship violation is something that, for example, when we have more records in a key value that is in the fact table that in the dimension, for example. So we have more registers from the key in the fact table that are not present in a dimension. So we can detect that as a relationship error or violation, like semantic link call that. Or, for example, a dependency violation is something like we have a dimension table of addresses, and, for example, the zip code is corresponding to different cities in this table. So those kind of things are also able to be detected through semantic links. So this kind of interaction will bring a participative role on semantic models for other types of users that they didn't have before, or at least it will have a few, just a little interaction with that. And we can consider, for example, three personas here, which is probably, as we can divide the data professionals, we can call the data scientists, the data engineers, and the data analysts or Power BI developers. And now, with this interaction with semantic link regarding the semantic models, this kind of personas will have different types of interactions on these models. Probably a Power BI developer will only want to develop the semantic model and share that to as a dashboard, or an analyst will want to build some analysis on that data. But, for example, a data scientist with semantic link will be able to, for example, use Python, which is a language that this user is comfortable with, to start interrogate the data from the semantic model without having to spend more time recreating all the logic in pandas to do is exploratory analysis or create some machine learning models. So basically, it doesn't need to pick all the data, all the tables that specific semantic model is already using, and to build his output. It can just go straight to the semantic model data and use that as their source of truth to get some value from that. Also, a data engineer, for example, as a data engineer myself, I really like to scripting and create data validation. So as a data engineer, I probably won't be able to validate the data from a semantic model that someone was developed. So that way, we can in a instantaneous, almost instantaneous and automatic way, we can guarantee the quality of dashboards. For example, we could create a middle layer between the development and production to run a script using semantic link to validate the data from a specific semantic model, and it can return some output to alert us for some issues. And of course, as a Power BI developer, there's some uh, things that we can leverage that. For example, one of the things that at least in my company we try to do a lot is documentation on data sets, and usually we try to build specific a specific Power BI or a specific document to each data set. And basically, with Semantic Link, we are able to, in a single notebook, we can build our functions in sequence to gather all the data that we need from a single data set and generate a new data set with that documentation. And we can store that documentation wherever we want, in a lakehouse, or we can output that in a document. But we can do that once we program it one time. We can do that for all our data sets as only a single time. So basically, this functionality, I see that as a new way to collaborate, which is basically the goal with Fabric. So, like I said, Semantic Link relies on Python functions. So at least for me, this collaboration is also achieved because of using this language as the base language of Semantic Link. Basically, Python is already a very evolved language with numerous libraries for numerous things, and these roles that probably weren't having much interaction with the semantic models were very comfortable with Python. So that is basically building a bridge to them so they are comfortable working and interacting with the semantic links. It's basically a language of choice for data scientists, data engineers. It will be able not only for you to build scripts only using semantic link. You basically can combine semantic link with other functions in Python, with other functions on data validation, for example. You can basically do everything using these kind of languages and technologies. Okay, so no more theoretical thing. Let's go straight to Fabric and let's take a look at some possibilities that Semantic Link allows us. So this is my first pause that I will open for one or two questions that we may have.
There's a question from Martin that says, can semantic links be used as an open source tool outside Microsoft Fabric, or is it strictly tied to the Fabric ecosystem?
Short answer, it's close to Fabric currently.
It cannot be used outside of that. Cool. No more question at this stage. Rui?
Okay, let's move on.
Yep.
So I'm here in Fabric. Basically, what I have here is I have some semantic models here that I'm going to rely on during the notebook that I will show to you. So basically, it's not the main focus to show what these semantic models have. They have measures, they have tables, the basic stuff. I will show you some functions over these semantic models, and if I need to add some specifications that these models have from others, I will tell you. No big deal. So let's start with the first notebook that I have here to show you, which is the basic stuff. Okay, so with the basic stuff, basically you'll able to do anything. Oh man, Uh, I've run these scripts before just to have everything ready, and now I lost the output. Great. Sorry for that. So, but basically, I'm going to run everything in maximum 2 minutes. But just to explain to you, so basically, this is for the ones that are not very used to this experience. So basically, I mean, in data science experience in Fabric using notebooks, one thing that you would need to do before was to install semantic link on your Spark session. So usually you would have to run this pip install semantic underscore link. But now semantic link is already installed in the Spark version here in the most recent Spark version in Fabric, so we don't need to worry about that. So the first thing that we need to do is to import these methods and these functions from semantic link into my Spark session. And the first thing the basic stuff that we need to do is import this senpai. The senpai basically will gather all the methods from semantic link, and some this will have the basic methods, but you will have in more advanced things that you need to do. You probably will need to import a few more classes, but I will show you that too. So the first thing that we need to do when we are start to exploring a workspace, probably we can, and only if we are working on a notebook, I probably want to know what are the data sets that I have in my workspace. So for that, I will. One of the functions that Semantic Lake has is this list datasets. I will make this a little bigger. Okay. So list datasets will basically run over your workspace and list all the datasets that you have present. So basically, don't worry about the code. I will make all these notebooks available in the end, so you don't need to take notes on that. So basically, the result of list datasets will give me the simple information on the datasets that I have, dataset ID, when this dataset is created, and then when it's last updated. Okay, so basic stuff. One more thing that we can do now is I'm going to pick a data set. In this case, I will pick this one, USA achievements. I will get this data set name on a variable, and I will use another method on semantic link to start investigating, to have a more deeply analysis on my data set. So another thing that we can do is list all the tables from a specific data set. And the method is simple, is call these tables and only relies in a parameter that is the data set. And with that, we have, again, basic information on the tables, not big deal, but I want to know more. I want to know what these tables have, which kind of data they store. So another function that allows to do that is the list columns. Basically, we can list all the columns present in the tables of a specific data set. We can list the columns from a specific tables. In this case, I will list the columns from this data set entirely, and basically it will get me from my semantic model all the table names, the columns that these tables as, types of data, which columns are hidden or not, the formats, the sources, if he has any category, display folders, sorted by. So all the attributes, the specifications for this, for each of these column are present in this metadata that we are bringing from our semantic model. So all the columns are listed here, and we can basically do with this whatever you want. Now I can take a look at one of these tables, and I want to take a look at the data that these tables has. And there's a specific function for that that is called the read table. Read table, I need to pass two parameters here, which one of the is the data set, the other one is the table name. I will take a look at the shipment table, that is my fact table from this data set, and basically this will list all the data. In this case, it will list an example of the data that is present on in this specific uh, table. But as I did this, as I created a new data structure to read the table shipment, basically now I have all the metadata from this table in my data frame. Okay, so this variable contains all the data that was read from the table in the semantic model. So basically I can start doing analysis, validations on this specific data, or I basically can build new models, new pipelines relying on this specific data. I can also there's a specific method also for saving this data in a lakehouse. If I want to start building a lakehouse of my own, and I want to get data that, like I said, is already validated from semantic models that were already spent hours working on that specific data, and I don't want to spend that time. I can just go there and read that data and basically store it in a lakehouse to display for another project, to make a new model, etc. The possibilities are enormous. But just an appointment. In Spark, you have a specific method to save this as a table in your lakehouse in Fabric data frame. In semantic link, you have a specific method to save a specific table to a lakehouse table, which is this one. Very simple. To lakehouse table, there's a few attributes, a few parameters that you may give, but essentially I'm just going to give the name of the table in the lakehouse and the mode, which will be override. Of course, to do that, you have to have a lakehouse attached to this notebook. As you can see in this lakehouse, which was already run, this is the data from my semantic model. So this is the way we can read the data. Let's do something else. Let's start taking a look at the relationships of my model. So, and for that, like I said, we have to import a few more things. Relied on relationships. There's a few functions that we need to import. The first one that we are going to see is a simple one, which is the list relationships. Like the tables, I'm going to list the relationships of this semantic model. And basically, we will have all the information relied on every relation that is created here, from table and column, and the table, the destination table and column, if it's active or not, which behavior is building this relationship, um, some modification time information. Basically, we will have the information that we need on what kind of relationships this model has. And if we want to see some a more graphical view of that, we can. There's also a function for that is the plot relationship metadata, that basically we can design our model, our diagram from our semantic model right here in notebooks. And one thing that I've talked on the presentation was, so I can take a look at these relationships. Can we find errors on these relationships? Can I make some data validation detection, for example? So yeah, relationships is one of the things where you can directly use semantic link with specific functions to find some violation on some relationship rules, or you can say good practices on semantic models. So basically, let's try to find. Let's see if there's some relationship violations in these relationships that I have in this model. So basically, for that, I will need to read all the data from every table from the data set, because I will need to run a function to check for these relationship violations over the data on those tables. So basically, what I do here is I will create a dictionary that will gather for every table on my data set. I will read the table in my list of tables. So basically, I will have all the table here in my notebook, and then we can use that data that is stored in these variable tables in this dictionary, and I will use these list relationship violations, and I will use that data combined with another parameter that is the list relation, the relationship from my data. So this function will cross this information to see if there's some bad relationships here. And basically, it detects two relationship violations here. One of them is the from the shipment table, that is our fact table, to the region table, that is our dimension. So basically, it is saying that it's not complete message. I don't know why, but basically, this says is that there are 56 values from in the shipment that are not present in the region. So 6 values that are not in the dimension table from the region PK. So this is something that usually can't happen. Is probably bad data, and we need to take a look. So this is one of the things that we can use semantic link to give us alerts on this kind of situations. And the same thing for the other dimension, for the product dimension. I have also 4 primary keys on products that are on the fact table that are not on the dimension table. So this is one of the things that I like, that is this kind of detections, that we can basically build a script, a notebook, and automatize this to run every time our semantic model refreshes, and give us some information if something goes bad with the data. So there's another thing on relationships that can be interesting. It can be used on some specific scenarios, that is pick up a semantic model. And this is we are talking about a phase of an initial development phase where we are start looking at our tables, and we don't have much information from our stakeholder on which data relates with which data. So we need to make some analysis on that. And for example, we have a model without any relationship, and I want to run a few semantic link functions to make him suggest, based on the data that table has, to make him suggest me some relationship that I can create. So basically, I'm going to use for that the same data set, but I've dropped the relationships. I will basically list any actual relationship that this data set has. Why? Because I want to guarantee that it doesn't suggest me relationships that I have already created on the model. I need to tell him the actual relationships, so he can suggest me other relationships other than the ones that I have. And I will do the same thing. So I have to store all the data from my tables in a dictionary, and I will use that in this function, find relationships. I will as a parameter, I will give all my tables data. I will exclude the actual relationships of the model, which are none in this case, but it will depend on the use case. I've also used this kind of this kind of parameters, the name similarity threshold will basically rely on the name of the columns. So basically, if the columns are, imagine if that this threshold was at 1, basically it will suggest relationships on columns that has the same name between multiple tables. But it was not usually the case. It can be, or it cannot be. So I will set a threshold a little lower than 100%, and the coverage threshold will rely on the data. So basically, if the data covers at least 0.7% of the time, it will suggest this as a relationship. As for good practice, the default of this parameter is 1, but as you've seen, we have some violations on relationships, so I have to have a coverage lower than 1. So basically, what this does is tells me all the relationships that I can create for my data set between the tables. It tells me the coverage from each other. Gives me some information here on unique counts, row counts. Basically, we can use this to help us when we are in the initial phase of building a semantic model, where we don't know as much as we need from that data. So let's take a look now at dependencies. This is another function from the semantic link, the basic ones, which we need to import another module, that is the dependencies model from the SempI. So let's use, for this purpose, the dependencies are applied on a specific table. So in this scenario, I will read the region table from my data set, the initial data set. Okay, so this is the data that I have. Basically, is a region which is the countries, the states, zip code, and cities. Okay, so basically, with the basic function, it's very similar to the relationship functions, which is the find dependencies. This will find the dependencies between all the columns from this specific table. So I have all the determinants, the determinant columns here and the dependent columns on the other side. And I can see also this as a graphical using the plot dependency metadata. So where this is interesting and where we can apply this information is to, again, to find some dependency violations on this data. So what I'm going to do now is I'm going to use this function, the plot dependency violations, which basically rely on more than one column from a specific table. Like you can see here, I'm using this function on this fabric data frame, which has the region metadata, and I'm going to try to find the dependency violations between these two columns, which is the zip code and the state. Basically, with this tells me is that I have, for a specific zip codes, I have more than one state, and I have two cases with that. And basically, this is an example of dependency violation, which are columns that usually would have unique values between each other. So one zip code for a specific it's singular for a specific state, or a specific city, and basically it's detecting that it's not the case in this data. So we probably need to take a look and see what's wrong. The same thing for the zip code and the city. There's a few more dependency violations that this finds, that probably we need to take a look. And the last thing on the basic stuff is the measures. So basically, we, like I said in the presentation, we can also run and see measure information from the semantic models on on our notebooks using these semantic link functions. So the measures functions are we don't need to import any additional stuff. I believe these are present in the basic library SciPy. So we just need to do that on the top. Let's use a different data set here that is these SL flights. It's a data set that I have a few more metrics, a few more measures created, so it's going to be more interesting. The basic function that we have seen here so far, the list, and then we are going to list measures, which are basic, telling me all the measures that are created in which tables, the expression that measure has, measure the data types, if it's hidden or not, display folders, and so on. So all the informations of all the metadata information from measures are displayed here. And basically, we can use this information to take a look at the measures and decide to run a specific measure in my notebook. So basically, we can run and evaluate in the notebook. It's basically, the function is called evaluate measure. We just need to pass as a parameter the data set where we want to run, the name of the measure, in this case, the sum of delays, which is this one, is a count rows. And we can also add some group by columns that we probably want to do. And we are going to run this measure group by the airline and the country airline. And we have the output based on the data from our semantic model directly on my notebook using the Spark engine for that. Another parameters that we can do is the filters. Okay, so there's a few parameters for every function that you can put. Also, after this meeting, you can take a look on the documentation, but you can play with your measures freely on your notebooks. There's a few more things that Semantic Link allows you to do in here on using the semantic link on notebooks. For example, accessing the DMVs from your semantic model. Okay, in this case, I'm searching these in this DMV for active relationships. We are also allowed to do that stuff. And we are also able to run some kind of SQL queries over our Power BI, over our semantic links. We need to set a specific configuration on our Spark engine for that. You can see that after on my Git when I share these notebooks. But you can basically also run a query like that over on your semantic link. In this case, I'm also querying a measure. I'm querying the data set that is this one, the SL flights. I'm accessing the metrics from this data set, and I'm basically doing a sum of a measure grouped by a specific column, which is their port origin. And I get the result from that, basically in SQL. Okay. So I have another notebook to show you. Do you have any questions so far, or can I move on?
Yeah, amazing, Rui. I was just, watching the questions. There are a lot of questions coming across. I will just show them on the screen and can move, on them one by one. So the first question is from Martin. It's actually install semantic links simply, then why we are not able to use outside of Fabric.
No, because before it was what I was explaining in the beginning. Before we needed to mainly when semantic link was on preview, we needed to do this pip install semantic link in Fabric. Okay, now it's not needed anymore. It's basically by default on the Spark engine in Fabric. Okay, but you can still use them outside of the Fabric environment. But you don't need to. That's why it's commented now. It wasn't before, but I don't need this pip install anymore here.
Awesome. So the next question from Maria: when to put override or another function for the lake house? It is goes back to when I think you write that table to your lake house.
Yeah, yeah. So it's not semantic link related, but basically when I do overwrite, so basically I'm overwriting all the metadata and schema from my from a lakehouse on that is already created, or when I'm creating a new table on the lakehouse. I believe I have the one here exactly. So basically, with this command, I'm creating a shipment table with a mode override. If the shipment is already created, I will overwrite the data with the new one. I can also use other methods, for example, the append method, which is basically append data to a specific table in my lakehouse. Um, Basically, if I'm doing an incremental extraction, something like that.
Yeah.
But Spark has a few more methods for that you can use for that.
So we've got two comments afterward, Martin. Amazing, and I do agree with Shamim. It is a great, really way to for documentation the semantic model. I like that. So the next question will be from Adil. How many rows does shipment fact table contains?
I
Because
believe.
the question is coming after that, which is related to this one, which is talking about pandas is not good in holding large amount of data.
Yeah. So this table for this demo purposes is just a 1,000 of rows. Okay. We are starting to use semantic link on a few projects, but not with that dimension. What with that is saying right now. Um, one thing that I'm interested in is to do some performance tests on semantic link which I didn't have yet, but it's probably one thing that I'm going to do in the future. I have some colleagues working on semantic link. I don't heard complaints on that matter, but I believe we didn't work with huge data sets with many million records which you are saying. But yeah, that is for sure something that I probably will do in the future. Do some performance tests and see
Sure.
what the
And yeah,
limitations
if you
on
can
semantic
just
link.
share it with our guys in the community, that would be great. Rui,
Yeah.
as you mentioned, Adil just wrote in the chat that if we have 100 million of records and want to try to show the semantic link, and then what? So that would be great if we have some answers or some performance tests on them. Adil, again, relationships related to relationships. If the primary and foreign key columns are different.
If I'm getting so, if I understand correctly the question, so basically when I list the relationships, it doesn't take a look at the column names at the primary key at the foreign key. It takes a look at the relationship itself that he has created. When I'm trying to find relationships, it can rely on the columns on the key names. But if I don't want them to rely on that because they are very different, I can just rely on the data that they contain, for example.
Sure. So another question from Wingshore, if I pronounce it correctly. How does it tell? Suppose I have columns with same name in two tables but different data type. Will the find relationship? I will actually find the relationship such as this or not?
It will depend on the kind of parameters that what kind of rules I want to tell this function to have. For example, in my scenario, I rely both in the name similarity and in the data coverage. For example, if I know that the, the data, I don't want to rely on the data that they may have. I can just set this coverage to 0, and I don't rely on that data. Okay, so if I want to don't I want just to rely on the name similarity. I need to basically adjust the parameters that I'm using in this function for that.
Okay. Another question, with the semantic link, can we able to extract only the data, or we can able to modify the semantic model?
For my understanding, I believe there's a new model that is coming up that is called Semantic Link Labs, and if I'm not mistaken, I believe it's not possible to change directly the semantic model. I can be mistaken because it's a very recent thing, and there's still new updates coming up on Semantic Link Labs. But with the basic functions, you can. The only thing that I know that you can do is there's a function where you can apply these the new relationships that the model suggests, but other than that you cannot read data from a table, do transformations, and save it over your semantic link or over your semantic model table. I believe that is not possible using the basic methods, but with semantic link labs, I don't know. Probably there's a new function that probably can be make you able to do that. For that purpose, I need to do some more investigation to make you 100% sure answer.
And the next question will be from Maria. So semantic link is machine learning applying specifically to semantic models?
You are not applying machine learning with semantic link, but you can basically use the data from the semantic models to build your machine learning models. That's the way I see it.
For sure. And the last question comes from Adil about measures. For multiple measures, we need to pass it as a list, or
You mean for example, to run multiple measures at the same time? For example, if that's the question, I haven't tested to run multiple measures at the same time. Only what I did in a few scripts that we mounted on the dev scope was running basically doing a Python iteration over the list of the measures, and which basically was happening is it's each measure was running each time. Okay, so I built a for cycle for my list of measures. I didn't need to pass it as a list.
awesome. So the questions are over for now. You can just keep going for the rest of your presentation.
Okay, how we are on time? So I have another notebook to show. We are okay with time. How much more minutes do I have? So just to
Maybe we can go for more 10 minutes,
okay, I will try to be
including the wrap up.
yeah. Okay, let's talk about a few more things that we can do here with Semantic Link. And basically, grid expectations are also are Python functions that were around for a lot of time by right now. So a lot of people are using these grid expectations functions on Python to implement data validations in data. We can basically implement this kind of data validation on databases, tables, files, data frames, whatever. So everything that you can run on a Python script, you can basically apply some of the functions that Great Expectation has in his libraries. Basically, before semantic link, the only thing that you will be able to do in the scenario, even on the scenario of Fabric, is to run data quality validations over the files on your one lake, even if there if files that are not very curated, like bronze and silver layers, or in a more enriched stage like gold layer, you can run data quality functions from Great Expectations. But and one thing that we cannot access was the semantic model from Power BI. Basically, semantic link, which will allow us is to make this bridge to use these Great Expectation functions. And Great Expectation is just an example, because we basically semantic link will allow you to use a lot of more Python functions, Python libraries over your semantic model. But basically, this bridge was made so now we can also use semantic link to use, for example, Great Expectations. And I'm talking Great Expectations in specific because I'm a big fan of data validation. One of the things that I like to do the most is to build these scripts that runs over the data on our stakeholders, on our lake houses, warehouses, to make sure everything is on is with good quality to and is delivered with good quality. And Great Expectations is one of the functions that I use the most, and I find it really interesting to see that they are using also semantic link to connect to these semantic models. So let's take a look in Fabric. Let's. I will try to be quicker this time. So basically, I'm not going to in very deep on the functions. Like I said, you can consult these notebooks after. But basically, I will need to import all the Great Expectations functions that I probably will need to use, and I have to import the Great Expectations, and I have to import some of the functions that we have specifically to validate some scenarios. I will show you right after. So the first thing that I'm going to do again is to pick a data set with a list data sets to apply my data validation. Okay, let's apply data validation over a semantic model. The first thing that I need to do in GX is to set up a context. So let's we use something like that, get context to start building a blank context where we are going to add a data source, add the assets that we want to validate, and to add the validations that we want to do over specific assets. So we need a context for that. And like I said, the first thing that we need to add to this context is a source, is a data set that we are going to validate. So this is where we are making the connection using the semantic link is with this add fabric Power BI. And basically what we're going to add here is a data set. The data set name is the retail analysis. That is one of the data sets that I have created here. I will give it a name. I will just add data source at the end. Just to keep the names coherent over when I'm explaining, just to make it easier to follow up. So I will add a data source, my retail analysis, that is basically the data set, and then I will specify data assets that are the assets, the subsets of data that I want to apply some data validations. In this case, I will show three examples. I will have a Power BI table, a semantic model table, which is in this case the table store that is present in my data set. In this case, I need to make sure that these tables, these measures, I know that are present on the semantic model that I'm going to validate. So when I run this function, this script, everything matches. Okay. So I will add this asset to validate, that is basically a table. I can add a measure to validate, which basically I can also do. So I basically will validate these total units grouped by year and month. And I can also validate DAX applied to my data set. And basically I need to pass this DAX string, which is a evaluate for a specific measure that will be called total units ratio. So basically this is the measure, the output of this measure that I will validate. And then I will create expectations, which is basically constraints that I will add for each of those three assets. Okay, so things that I will, like the name, expect from that data. So the first thing, I will create an expectation that I will apply to the store table. Okay, and basically I will add two expectations in this case, and I'm not. I don't need to, since I'm using great expectation functions, I don't need to write a lot of code to validate these kind of things. I can just benefit from these libraries and apply these data validations. In this first expectation, I'm basically using this configuration, which is expect column values to be a valid zip code. This zip file, it means the format of the zip code, the five numbers, and basically the column that I will apply this expectation configuration is the postal code. Okay, which are going to be the postal code from the store table. I will also add another expectation, which is the table row count to be between, and I have a minimum value and a max value. Okay. And every time I create these expectations, I will need to add the expectations to my contest. The same for other expectations that I create. This time for the measure, this again is an expect column values to be between, and I want this my column total units, the measure that I need to validate, as to have a minimum value of of this number. I can just set a minimum value. I don't need to set a max value. And again, I add this expectation to the context. And finally, for my DAX measure, I will want to again set an expectation for the total units ratio as a minimum and a max value also. Okay. So I have everything created, everything that I need. Let's go for the validation. And for that, I need to reunite all these assets and expectations that I've been creating and basically build a configuration file to that I be able to run, which is called a checkpoint. Um, this checkpoint config, which basically takes a name, I'm calling retail analysis checkpoint. The validations that I will do, basically this is the structure. I'll need to tell which expectation I will run, so which validation I will run, and the batch that I will use for that validation. In this scenario, for the first example, I will validate the data source, that is the first thing that we define, and the asset, that is the table. Again, for the measure expectation, we do the same, and for the DAX expectation, we also do the same. Okay, and basically we add this checkpoint configuration to our context here, and we have our checkpoint ready to be executed. And this is basically the only thing that we need to do after all these configurations. We do the checkpoint run, we execute this. This will calculate and run all the metrics over my data set, okay? And in the end, we can display the results, which will be in a JSON structure, we can run a few codes just to have this in a table format and in a more readable format. And basically, the results are something like this, which is we have the batch ID, that means the validation that we run, the type of validation that we did, which is basically the function, the great expectation function that we have used over our semantic data. In this case, we have two batches of validation for our store asset, which are the valid zip code and the row count to be between. another one for the total units asset, and the total units year over year, which is the measure and the DAX measure. We have a flag which tell me that if it's a success or not on the validation according to our parameters. We have one that is not successful. It was expecting an interval, okay, like we have seen here, between the value of this measure needs to be between 0.8 and 1.5, and basically it found that three actually values from the measure, which we can see here, that doesn't respect that constraint, which we can also see a preview of those values. And basically after that we can start to build some diagnosis over this data to take a look on what happens. So we can basically build a script like this and have these to run automatically in subsequently after our semantic model refreshes, for example. And basically we can benefit from the semantic link functions to run the DAX function that we have in the beginning, and run the function to take a look at the values that didn't match the constraint, which is the January, the April, and the July. Okay. So I'm going to wrap this up to go to the end topics that I just want to take real quick view. The semantic link labs, which I've talked while I'm answering some questions. The semantic link labs is something that Michael Kowalski is working on and is keeping updating is this Git repository, semantic link labs, with a few more information, a few more functions. I've tried to follow up on these new methods that you can basically. Semantic link labs is an extension of semantic link. So there's a few more methods that you can use that semantic link solo doesn't bring. Some of those things that I found very interesting, and I will recommend you to take a look, is a direct lake migration from direct query and import mode. Okay, so basically, Michael Kowalski, if you access this Git, you will find step by step on how you can use these semantic link labs functions based on semantic link to access your direct query or import mode semantic model, and start to with only one notebook to do a migration to a direct lake semantic model. You can also run a few interesting things. For example, you can run BPA rules directly on your notebook over a semantic model. You can run Vertipack Analyzer in notebook also, and you can also, and I found this very interesting. You can do model translation in very quick seconds over some semantic models too. So basically, like I said, direct query and import mode migration to direct lake is one of the things that this library really allows you to do that in a very easy and clean way for the majority of the things. Okay. Basically, you will need to you enable XML read and write in your admin portal to access all these objects, all the objects that these functions need. Okay, I will explain the step by step, but we are just with a few minutes. But which basically, if you're going to Michael Kowalski repo, you will find this exactly notebook that has all the step by step to migrate your semantic model to direct lake. Okay, so I really recommend you to do that if you need. If you want to see that on video, there's also a very good video on of a session specifically on using the semantic link labs for this purpose. If you are interested, go and watch it. And of course, and that is some example of the PPA rules that you can run on your data set, and the Vertipack analyzer that you can also run on your data set. So, final slide, what semantic link offer us. So basically, it's all about automation, as I see. Okay, there's a lot of functions that we can, and basically we can access almost everything from our semantic models, and we can start to build automation using leveraging the Python language to do that. I can some examples of automations that I've already did in some projects in my company. We leverage semantic link a lot for documentation. That's one of the first things that we did, is basically build a semantic a notebook that will read all the metadata from every semantic model in a workspace. It will save all that information in a lake house, and basically we had a model that gather all the documentation from every semantic model in a specific workspace. So some clients would enjoy that, just to so they can access it and export it as they want. In other cases, we basically gather all the information on a specific structure, and we save that in a file to be used as a documentation also. Also, data quality. One of the best things that we have did is really leverage these data quality functions over the semantic models. We basic some most of the times, most of the errors on data quality were detected by our stakeholders, and that was not fun. It's not great to have someone that relies on that data daily in a daily basis to tell us that something is wrong. Basically, with these functionalities, we were able to know possible errors or possible mistakes that we need to fix quickly, even before the stakeholder seeing that data. But yeah, I believe is that. I think we can go to the riddles now. What you think?
Sure, sure. Thank you very much. Rui, this session was one of those sessions that I didn't really want to finish. I am really, excited to, have this topic today. We have actually this topic today, and the most part of that I, personally can benefit from is the validations and finding the issues in my data set, as a data engineer, and who wants to just is looking for data cleansing sometimes, right? And
Yeah.
some people, in the Power BI side of that, they would like to have some documentation, which is great. And as you mentioned, it has a lot of other
Possibility. There's a lot
benefits.
of possibilities. Yeah.
Yeah, and there are two questions before we move forward to the riddles. So, Adele, any possibility of sharing the notebooks and presentation if possible?
The presentation, I will so I will share in the end a link tree via QR code. I have not. I didn't have the presentation there in the links, but I don't know. Maybe I can send to you the presentation. Um, I if I can send to you and you can share the presentations. I don't know, but if you access the link that I will show it in the end, right after this slide, you can access the notebooks that are on my Git. Okay, we'll have a link for that, and for the presentation, just send me a message on LinkedIn, and I will share it with you. Okay, I think it's better that way.
Yeah, I see. Since the riddles are visible, people are just trying to answer them, but before answering
Okay.
them, we just let's answer the questions and then we can move forward with the riddles. A question from Maria says, when using Fabric, would you recommend to use semantic link instead of DAX Studio for check of validations, relationship violations, etc., etc.?
I didn't semantically. Oh, oh my god! Let me. Would you recommend semantic link instead of Flask Studio? It will depend on the kind of user that you are. For example, for me, I usually don't use Dax Studio. I didn't. I don't work with Power BI also for a long time. Okay, so I'm very deep on a data engineering role where I basically working on ETL, notebook, data preparation, and I don't have access directly to this kind of tools, and probably for me at least it's easier just to run a quick function here in a notebook and have access to the data. It's more practical for me, at least. I believe it will depend on the kind of user that is going to is going to use some specific functions
Cool.
for that.
Yeah. Awesome. So let's jump into the riddles. The answers is coming up.
Okay, oh,
So I will start from the very first answers. So
let, let
which
me.
is coming sooner than we have the winners there, right? So can you share your?
Yeah,
Oh,
yeah, yeah.
let
Here
me
we go.
let me share. Yeah. So, riddle number one, I'm a data structure who stores all semantic metadata. Who am I? And number two, I'm able to show you all the relationships from a semantic model. So, I just show the answers one by one. And Rui, you can just tell us who is the winner. So, for it's a semantic metadata repository.
No,
No. Martin says model or metadata store. No.
no. It has a name.
Yeah. Deborah says semantic link for number two, for question number two.
It's a function from semantic link.
Yeah. And Martin says second question answer is diagram view or relationship view.
You are close.
Shamim says uh, fabric data frame for number one, and for number two, semantic link.
So yeah, fabric data frame is correct, but semantic
First
link
question. Yeah.
is a function from that.
So for number two, again, semantic link. Mm-mm. Uh, No,
Yeah,
Deborah, sorry, your answer just came after, Shamim's answer. But thank you for being active. Adil, data frame again. And for number two, list relation.
exact, correct.
Awesome. So I think we've got two winners, right? Shamim and Adil, right? So Shamim for the first question, fabric data frame, and Adil for the second question for list relationship. Awesome, awesome. Just reach out. For the winners, reach out to our LinkedIn page or my chat and learning room. We can just set up your give a voucher actually for the Microsoft exam, but keep in mind that it is you know uh, going to be great to celebrate together. If you're taking exams, just ping us and we can just celebrate it together. And yeah, and here's the QR code for Rui. You can just provide the feedback. That would be awesome.
Yeah,
And there are two more. Yeah, one more. Adil says DAX study can connect to the semantic model, so all this come since from it.
didn't quite get the
Uh,
answer.
the DAX study can connect to the semantic model. So
Yeah.
all these come these seems from it. I'm not sure how. Yes,
Sorry, I didn't get it.
I didn't get that. And Adil,
Thanks.
just thanks a lot for sharing your knowledge base, and Shamim also thanks for the great presentation. It's useful, cause yeah, cases will be really. And Deborah, great job. Thank you very
Thank
much
you.
for your support. Luis, thank you both for the session. That
Thank
was
you.
insightful. Awesome. So let me just share my screen. We have done with this session. The recording is available on YouTube. After this session, and stay tuned for the next two sessions that we've got there. And follow us on YouTube and LinkedIn, and stay tuned for the upcoming sessions and updates. And also feel free to join the learning rooms. There you can just find the other learners or experts. And again, Rui, thank you very much for
Thanks
your
a lot.
presentation. That was awesome. We are almost an hour and a half, but that was
Yeah,
amazing.
it was really fun, really interesting, really good questions. Really loved
Yeah,
it.
awesome,
Thank you a
awesome.
lot.
Thanks, attendees. It is the making actually the community, right? It is the mean of community. We ask and we help each other with no doubts. Actually, cool. If there is anything to add, Ray, feel free. If not, we can just wrap it up, and wishing the attendees a
Mhm.
weekend.
So yeah, any question that you may have on the specific scenario on Semantic Link or any other aspect in Fabric, feel free to reach to me via LinkedIn. That's where I mainly the main social network or whatever you want to call it that I use mainly. So feel free to ask any question that you have. I also really invite you to follow me on Medium. That is where I basically every week share a new topic in Fabric, Databricks, or in another technology around data engineering and analytics. So I really invite you for that to see my content, discuss about it, have questions, and the usual stuff. And thanks a
Awesome.
lot for
Awesome.
everyone.
Cool. With that said, we can say goodbye and enjoy the rest of your
I,
weekend. Which Maria asked a question? Sorry, I didn't get that again. Adil. Cool. We can just wrap it up. Enjoy your weekend. Have a good one. Cheers.
Thanks a lot. Bye bye.